Today's lesson focuses on the concept of stoichiometry. So as we get into what that will entail, let's look at our learning targets for today. So after this lesson, you will be able to explain how chemical equations support the law of conservation of mass. We are going to define what that is in an upcoming slide. You will also be able to identify a mole ratio using a balanced chemical equation. And at the end of this lesson, you will be able to perform stoichiometric calculations with mass. Now, we will also be reviewing balancing equations and a few reaction types through this lesson. So let's start with the question, what is stoichiometry? So stoichiometry is a quantitative relationship between reactants and products in a chemical reaction based on the law of conservation of mass. Remember, quantitative has to do with quantities or amounts of reactants and products. And simply put, the law of conservation of mass simply means that matter cannot be created or destroyed in a chemical reaction. Given this concept, we can state that the mass of reactants will always equal the mass of the products. So if we have this simple generic equation to look at, A plus B equals C plus D, given the mass of A as 5.3 grams and an unknown mass of B, but also given the masses of the products, 2.6 grams for product C and 4.8 grams for product D, we can use simple arithmetic to determine the mass of B through subtraction. All you have to do is add up your products and subtract that sum by the mass of the reactants to obtain the mass of your unknown B. Okay, so through that calculation, we can determine the mass of B is 2.1 grams. So if we know the quantities of the reactants, we can then predict or calculate how much product can be obtained. Here is another example of the law of conservation of mass applied. So here we have a balanced equation. It's a decomposition reaction. Hopefully you see that from the fact that there's one reactant broken down into two separate products. You can tell that it is a balanced equation because we have coefficients in the right spots. Okay, so the question here is that we're to determine the mass of aluminum oxide, aluminum, and oxygen using the above equation. So the first thing we'll do is we'll bring down the 2 moles of aluminum oxide. And so all we did was just copy this reactant along with its coefficient down here. And now through dimensional analysis, we're going to be able to calculate how many grams that is. Okay, so you're going to then draw your T-chart or your dimensional analysis setup. And then remember, in dimensional analysis, we always want to cancel out the given label. And the way we do that is we just simply copy the label down below. And remember, during mole conversions, you always use 1 mole of aluminum oxide or whatever the compound is that's given to you here, and then find the mass of that substance using the periodic table. So we're going to write 1 mole of aluminum oxide equals 101.96 grams of aluminum oxide. So just to review, you need to use your periodic table to come up with this number. So aluminum here, there's 2 atoms of it in this formula unit. So you would take the mass of aluminum, 26.98, rounded to the hundredths, from your periodic table and multiply that number by 2, and then add it to the mass of 3 oxygens. So the oxygen atom, the mass of one of them is 15.9994. So we're going to go ahead and round that to 16.00, multiply that by 3, add these 2 together, and then you should get the 101.96 grams as your answer. Okay, so now you can see that the moles cancel, and all you have to do is multiply the top numbers here in this dimensional analysis setup to get your product. So you get 203.92 grams of aluminum oxide. Okay, so now we're going to take the 2 products and do the exact same thing we did with the reactant, convert them both to grams. Remember, the coefficients represent the number of moles in the given equation. So for every 2 moles of aluminum oxide that decompose, you get 4 moles of aluminum and 3 moles of oxygen. Okay, so now we're going to take the 4 moles of aluminum and do the same thing, bring in your dimensional analysis chart, and then set up your conversion factor. So 1 mole of aluminum equals 26.98 grams of aluminum. Multiply the top, and you will get 107.92 grams of aluminum. And then finally, we're going to do the same thing with oxygen. So you have 3 moles of oxygen at the top. Remember, oxygen is diatomic, so don't forget to put that 2 there. When you are writing the products in a decomposition reaction, you find that element by itself. Okay, the next step is bring in your dimensional analysis table and then set up your conversion factor. So 1 mole of oxygen equals 16 times 2 is 32, so 32.00 grams of oxygen. Multiply that across and you get 96.00 grams of oxygen. Okay, now that we've done that, you hopefully will be able to see that if you take the 2 products and add those masses together, you will get 203.92 grams. Notice how the 2 numbers, the masses of the products and the reactants, are the same. Okay, so we've proven the law of conservation of mass in this problem here, where products equal the reactants. The mass of the products equals the mass of the reactants. So why do we need stoichiometry? Well, these calculations allow us to predict the outcomes of a chemical reaction. So let's look at this equation. Calcium oxide plus water produces calcium hydroxide. So in industry, this reaction has multiple purposes. For example, slaked lime or lime, also known as calcium hydroxide, was used in the construction of mortar and plaster to construct ancient pyramids in Egypt and also the ancient statues in Jordan dating back several thousand years. Calcium hydroxide is also used in the paper manufacturing industry to convert wood into wood pulp. Another use for it is in the field of dentistry. Calcium hydroxide is used during root canals. It's got antimicrobial properties and also helps in to reduce swelling. Another use for calcium hydroxide is in hair products. It's actually an agent involved with straightening curly hair. So these are just some uses for calcium hydroxide. So this is an example of an industrial process. Through stoichiometry, through these calculations, we can determine how much calcium oxide, how much of this reactant would be needed to produce a desired amount of calcium hydroxide. So in doing these calculations, there are certain steps to solve. So the first step I would start with is to determine the given value in the problem. So what are you given? Are you given moles? Are you given grams? Are you given liters, representative particles? Remember, representative particles is a term that encompasses formula units, atoms, ions, molecules. If you're given anything other than moles, you must convert that given value to moles. Okay, also make sure you have a balanced equation before you begin. Oftentimes you will be given a balanced equation, but in the problems that we're going to do together today, you will be asked to write out the balanced equation yourself. Next, you want to use your mole ratio. So that's why it's so important to have a balanced equation. The mole ratio will use coefficients from the balanced equation in the dimensional analysis setup. So when you're incorporating the mole ratio, this is what it's going to look like. You'll put moles of your given value at the bottom and moles of what you want to obtain at the top. If the question is asking you to obtain moles in your final answer, you can stop here. That would be the last step. But in most problems, or in many problems, you'll often be asked for an amount or a quantity other than moles, such as formula units or molecules or grams or liters. And in that case, you'll have to take your dimensional analysis setup one extra step to convert to the desired unit. Okay, so remember to use your conversion factors. We already incorporated the use of 1 in the problem earlier, illustrating how the law of conservation of mass works. So just to remind you, these are your conversion factors. So for moles to grams, remember to use your periodic table to determine the molar mass of the element or compound that you are evaluating. If you are asked to determine the particles, so representative particles, including formula units, molecules, ions, or atoms, you will always use Avogadro's number. So whether you're converting your given value to moles, you'll be using Avogadro's number, or whether you're converting from moles to a representative particle, you will use Avogadro's number as 6.02 times 10 to the 23rd. We're going to just keep it rounded to the hundredths to make our lives a little simpler. Okay, and then finally, sometimes you might be asked to obtain liters of a gas at standard temperature and pressure. So you will often see that term abbreviated as STP. So just remember that 1 mole of any gas at standard temperature and pressure will always occupy 22.4 liters of space. So let's look at some mole ratio examples. In this equation, again, the decomposition of aluminum oxide, you're given 4 moles of aluminum and 3 moles of oxygen for every 2 moles of aluminum oxide that decompose. So you're just going to simply look at the coefficient to determine the mole ratio of what's being asked for in the question. So for aluminum oxide and aluminum, when you're comparing those two, you will just simply write 2 moles of aluminum oxide to 4 moles of aluminum. Okay, if you're evaluating aluminum and oxygen, you could use the coefficients again here, 4 moles of aluminum to 3 moles of oxygen. So that would be your mole ratio. And take a moment, pause the video, see if you can do the last one on your own, and then I'll show you the answer. Okay, so 2 moles of aluminum oxide to 3 moles of oxygen. So hopefully you were able to come up with that one on your own. All right, let's look at an actual stoichiometry problem now. Okay, I've given you a clue here to show you what to expect in terms of how we're going to set our problem up. So this is going to be a mass-to-mass relationship. So what we're going to be given is a number of grams. We're going to have to convert that to moles, set up our mole ratio, and then finally change our moles into grams. Okay, so let's look at what we're given in this problem. Sodium chloride is produced from its elements through a synthesis reaction. What mass of sodium is required to produce 25 grams sodium chloride? So our given value is going to be 25 grams of sodium chloride. Okay, and now we're going to figure out our goal. What are we looking for? So what mass of sodium? That's the question. So if you recall, in class, I handed out a visual aid, a diagram for you that had a pair of hands on it. Now, this is a diagram that you can use or lose depending on if you feel that it's useful to you. And I'm just going to remind you how to implement it. So on the left hand, we placed a dot of a certain color and we call that dot mole A. And then on the right hand, we placed another dot and we call that moles of B. Okay, so generally in the simplest stoichiometric setup, you're simply going to convert moles of A to moles of B. That's all you have to do. And the simplest stoichiometric setup would then be a one-step problem. Okay, but life's not always that simple. Sometimes we'll be given units that are grams instead of moles. Okay, and then sometimes we might be given representative particles, and you remember what those terms, or what that term encompasses. And then finally, you might also be given liters, so just keep that in mind. All right, so if you're given any of those quantities, any of those units instead of moles, remember to convert that quantity to moles. That's going to be your first step in the stoichiometric setup. Once you have converted to moles, then you will set up your mole to mole ratio. So you'll convert moles of what you're given to moles of what you're trying to obtain. So in this case, we're given moles of A, trying to obtain moles of B. And then if your problem is asking you to obtain moles of B, you will stop there. But in the example that we're about to attempt, we're being asked to determine the number of grams. So that will take you one step further to convert your moles of B to grams of B. Okay, so that's our little visual aid to remind us of the pathway. Okay, and then remember, when you're setting up your mole ratio, it's always going to be moles of what you want. So that would be moles of B at the top over moles of A at the bottom, moles of the given value. Okay, so back to the problem. So once again, we have the 25 grams of sodium chloride. That's what we're starting with. We're looking for the mass of sodium. And here's our pathway, starting with grams, going to moles of A, then going to moles of B, and then finally ending up at grams. Okay, and then from the problem given to us, you can see that moles of sodium chloride is what is represented by moles of A, and the moles of B are going to be represented by the moles of sodium. Okay, so in the mole ratio, they will look like this. Okay, so here we have a couple of things underlined for us. This is the same problem. I've just underlined for you some key terms to pay attention to as you're coming up with your balanced equation. So sodium chloride is produced. So can you guess what side of the arrow that this compound will end up on? Hopefully you guessed the right side, which is where the products belong. So it's produced from its elements. So hopefully you can see that the elements involved are sodium and chlorine through a synthesis reaction. So through this, we can clearly see that because it's a synthesis reaction, we're only going to have one product, which in this case is sodium chloride. And it says what mass of sodium, so that's going to be one of our reactants, is required to produce 25 grams of sodium chloride. So take a moment, pause the video if you need to, and write down the equation with the reactants and products in it. All right, so hopefully you came up with this reaction. Remember, chlorine is a diatomic molecule, so remember to put that 2 in there as your subscript. And now the only thing that's left is to balance the equation. So take a moment, pause the video if you need to, and plug in your coefficients. All right, so you can see that the chlorines are imbalanced, so we're going to go ahead and put a 2 there as our coefficient on the product side and follow that up with another 2 on the reactant side in front of the sodium. Okay, now that we've got our balanced equation, we are now ready to solve. So I'm going to pause the video and head over to my whiteboard so we can work out the problem together. Okay, so here I've written out the reactants and products, and we're just going to start with the given value in the problem. The given value is 25 grams of sodium chloride. Okay, and remember the first step, change grams to moles. Okay, so just to help us stay on target with the stoichiometric setup, I'm going to just write the pathway down below so you know what steps I'm about to take. So the first step is change grams to moles, and then we're going to set up our mole ratio. And then finally, because we're being asked to determine the mass, we're going to change our moles to grams. Okay, so those are our steps. That is a total of 1, 2, 3 steps in our stoichiometric setup. So we're on the first step right now. Okay, I'm going to set up my T-chart or my dimensional analysis table here. Now, in order to get rid of the grams of sodium chloride, you need to use your periodic table and figure out the mass of sodium chloride. So pause the video if you need to figure that out. Okay, so hopefully you were able to figure out that the sodium mass is 22.99, chlorine is 35.45, add those together, and you get your 58.44 grams. Okay, so we've taken care of changing grams to moles, so we've taken care of the first step. Now you'll notice that the grams of sodium chloride cancel, so now we have moles of sodium chloride at the top, and that's what we want to get rid of. So our next step is our mole ratio. So guess where moles of sodium chloride is going to go? You guessed it, down at the bottom. Okay, in our mole ratio, remember, we put moles of what we're given at the bottom and moles of what we need to obtain at the top. So the question's asking for sodium. So we need to convert to moles of sodium first and incorporate that in our mole ratio. All right, now for the mole ratio, remember to use the coefficients from the balanced equation. So we're given 2 moles of sodium here. So I'm going to put a 2 in this spot. And then also at the bottom, we're given a 2 in front of the sodium chloride. So I'm going to put 2 moles of sodium chloride down here at the bottom. So now with the coefficients plugged in, I've completed the mole ratio step. Now I'm on the final step where I need to convert to grams of sodium. Okay, so you'll notice once again, these labels cancel and we have one more step to go, and we're going to go ahead and set that up. So pause the video and see if you can set that last step up on your own. Okay, so 1 mole of sodium equals 22.99 grams of sodium. So now all that's left is making sure our labels cancel and making sure that we have the right label that we're supposed to end with. So, and we do. We changed to finally to grams. So now all we have to do is multiply the top and divide it from the bottom. Okay? So go ahead and pause the video, take care of that calculation. Remember to use significant digits based on the given value in your final answer. Did you get 9.8 grams of sodium? Hopefully you did. Remember, we have 2 significant digits in our final answer. Okay, we're going to look at the next problem. So here we have example 2. In this example, if you look at the first statement here, it says mass to mole relationship. So that's my clue to you. So you can see that we're going to be given mass. We have to convert that to moles and then set up our mole ratio. And because we're going to be asked to determine a number of moles, we get to stop after the mole ratio step. So it's going to be a shorter problem than what we saw earlier. Let's look at our question to determine our given value. How many moles of iron 2 bromide would be needed to react with potassium phosphate to produce 18.54 grams of iron 2 phosphate? So you can see immediately that our given value is 18.54 grams of iron 2 phosphate. And we're being asked for moles of iron 2 bromide. Okay, let's quickly review our pathway using our visual aid. So we're going to start with grams, convert to moles of A, substance A, and then using the mole ratio, convert to moles of B. And that's where we will stop. Okay, so back to the problem. We're going to go ahead and attempt to write our balanced equation by determining our reactants and products that are given to us. So it says in the problem, how many moles of iron 2 bromide would be needed to react with potassium phosphate. So right away we can see our 2 reactants are given to us there. And then it says here to produce iron 2 phosphate. So that's going to be one of our products. So I say one of our products because hopefully based on our lesson on predicting products, you should be able to see that because we have 2 compounds in our reactants, there are some missing elements unaccounted for in this problem. So take a moment, contemplate what our products will be, and see if you can write out an equation. Remember to pause the video if you need time to do that. Okay, so hopefully you came up with the correct formulas for the reactants and products. Remember to note your oxidation numbers when writing your formulas correctly. So iron's oxidation number is +2, and we know that because of the Roman numeral here in the name. Bromide's oxidation state is -1. So when you're writing the formula out, we end up with the 2 as our subscript for the bromide. And then over here, we've got potassium phosphate. Potassium's oxidation state's +1. It's an alkali metal. Phosphate's -3. So remember to put a 3 as your subscript for the potassium. And then on the product side, we're given, remember, iron 2-phosphate was one of our products. So that left potassium and bromine unaccounted for. Okay, hopefully you were able to recognize that this was a double replacement reaction. So our other product is just simply KBr, potassium bromide. Remember, alkali metals are +1, bromide is -1, so no subscripts needed here. And iron, its oxidation state is +2, phosphate's -3. So remember to put the subscripts down as shown here. Okay, the next step is to balance the equation. So pause the video if you want to take a few moments to do that. And hopefully you can see that the only coefficients needed here are a coefficient in front of the iron 2 bromide. So that will make the atoms of iron equal. Balance those out. We have 3 on both sides. And then now, because we have 6 bromines, we need to, on the product side, put a 6 in front of the potassium bromide. Okay, and then finally, to make sure the potassiums are balanced, you will need to put a 2 as your coefficient in front of the potassium phosphate. Okay, let's review our pathway for this problem. So we're going to start with grams, go to moles of A, moles of B, and stop there. And then remember, your mole ratio for this problem will be moles of what we're trying to obtain at the top. So in this case, that's moles of iron 2 bromide. And then at the bottom, we should have moles of what we are given at the bottom. So that would be iron 2 phosphate. Okay, now that we've achieved that, we're ready to solve. So here's my whiteboard setup for you. This is just a reminder to show you our pathway again. So we're going to be given grams. We have to convert that to moles and then set up our mole ratio, and that'll be our final step. So this is going to be a 1-2 step problem. Okay, so let's take a moment to set up our given value, 18.54 grams of iron 2 phosphate. These formulas are kind of lengthy here. Okay, so now our next step is to set up our conversion factor. So pause the video to see if you can do that on your own. Hopefully you were able to come up with the correct mass for iron 2 phosphate. Remember to use your periodic table. There's 3 atoms of iron in this formula unit, so you would need to multiply 55.85 by 3. There's 2 atoms of phosphorus there, so remember to multiply 30.97 by 2, and then there's 8 atoms of oxygen, so remember to multiply 16.00 by 8. Once you have those products, add them together and you should get the molar mass of iron 2 phosphate. All right, so see if you can pause the video and do the last step of the stoichiometric setup. The last step is our mole ratio. So remember, moles of what we're given go at the bottom of our setup, and moles of what we're trying to obtain go up at the top. Remember to use the coefficients from the balanced equation for your numbers in these spots here. So at the bottom, notice how there's no coefficient in front of the iron 2 phosphate. So all you have to put down here is a 1. And then up at the top, iron 2 bromide has a coefficient of 3 in front of it. So that's what we're going to put in this spot here. Okay, check to see that your labels are going to cancel. So that's how you know they're set up correctly. So you can see that the iron 2 phosphate will cancel, the grams of iron 2 phosphate, And then you can see the moles of iron 2 phosphate will also cancel. And then we will get moles of iron 2 bromide as the units and label of substance in our final answer. Go ahead and do this calculation on your calculator and see if you can record your answer in significant digits. So after multiplying the numbers up at the top and dividing by the numbers down here at the bottom, you should have gotten 0.1556 moles of iron 2 bromide as your final answer. Let's move on to the third example. In example 3, the problem states how many grams of calcium sulfide would be needed to react with 6.32 grams of silver nitrate to form silver sulfide and calcium nitrate. So we can clearly see our given value is 6.32 grams of silver nitrate. So go ahead and identify that and then figure out what your value that you need to obtain is. So that's going to be grams of calcium sulfide. Let's review our pathway. So we're going to be starting with grams because that's our given value, converting to moles of that first substance, moles of A, and then setting up our mole ratio to convert to moles of B. And then finally, since we're asked to obtain grams of the unknown substance, that's what we need to convert to. Our mole ratio will then look like this. Moles of calcium sulfide, that's what we need to obtain, over moles of silver nitrate. Okay, so back to our problem. Let's identify the reactants and products that are going to go into our equation. So our first reactant, calcium sulfide, is going to react with silver nitrate. So those are your two reactants. Hopefully right away you can see that because we have two compounds, we're going to end up with, again, a double replacement reaction. Okay, our products that we form in this process are silver sulfide and calcium nitrate. Take a moment to pause the video and see if you can write down the equation with reactants and products on your own. Calcium sulfide plus silver nitrate yields silver sulfide plus calcium nitrate. So you can see the subscripts. Remember, +2, -2, +1 for silver, -1 for nitrate. Silver, again, +1, -2 for sulfide. So remember to put a subscript of 2 next to the silver. And then finally, calcium nitrate. Calcium's +2, alkaline earth metal. Nitrate's -1. So remember to put that in parentheses so you can put the subscript outside of it. Go ahead and take a moment to balance the equation. And the only coefficient that we need is a 2 in front of the silver nitrate to balance everything out. Now that we balanced, we are ready to solve. This problem is similar to the first example we did together, where we're going to be converting from grams to moles and then setting up our mole ratio and then finally converting back to grams. So take a moment to see if you can set up the grams to moles part of your stoichiometric conversion here. So in this first part of the setup, hopefully you were able to obtain the molar mass of silver nitrate using the periodic table. So remember, the mass of silver is 107.87, and then you're going to add that to the mass of nitrogen as 14.01 plus 3 oxygens. 3 times 16 is 48, so you're going to add 48 to that, and you should get 169.88 grams as your mass for the silver nitrate. So you can see these labels cancel, so we've successfully converted to moles of silver nitrate. So this first step is done. We have 2 more steps to go. See if you can pause the video and set up your mole ratio. So remember, in the mole ratio, moles of what we have, the given value, go at the bottom of our setup, and moles of what we're trying to obtain go up at the top. Now, in the balanced equation, moles of calcium sulfide, we do not have a coefficient present there. So you know what that means. Just put a 1 there in that space. And then for moles of silver nitrate, looking at the balanced equation, we have a 2 as our coefficient. So we're going to transfer that down here into our mole ratio. Okay, so we've successfully converted to moles of calcium sulfide. Now, if the question was asking for the amount of moles of calcium sulfide, we would be complete with our problem. But since we have to record our answer in grams, we need to take it one more step. So see if you can set this next part up on your own. Notice in this final step that you must put moles of calcium sulfide down here at the bottom so that these units can cancel. And then calculating the molar mass of calcium sulfide will get you 72.14 grams of calcium sulfide. So based on the periodic table I'm using, the mass of my calcium is going to be 40.08 added to sulfur, which is 32.06, to give me a total of 72.14. Now that we have our setup complete, go ahead and multiply the top, divide it from the bottom, and record your final answer in significant digits along with the units and the label of the substance. Did you get 1.34 grams of calcium sulfide as your final answer? If so, you are correct. So now that we've completed this lesson, you should be able to do any mass to mass or mass to mole or mole to mass stoichiometric calculation. If the question was asking you to come up with formula units of calcium sulfide, then the only change you would have to make on this step would be to use Avogadro's number in place of the molar mass. So it would be 1 mole of calcium sulfide equals 6.02 times 10 to the 23rd formula units of calcium sulfide. And then you would just solve mathematically the way you solved this problem. Okay?